if you use this equation and you solve what is the state of stress under that condition, which is not simple at all, you will find out that in this direction, you want to have compression. And that makes sense, right? Because you got to carry all those forces that are going down and the reaction which is going up from here. But in perpendicular direction, you're going to have tension. And let me explain. Let's take a bit of time to explain why this is like this. So let me draw the same piece of rock. That doesn't look quite circular. Let me improve that. Okay, so there's a rock. You apply a point force over there. Because of the shape of the rock, the compression lines are going to go down like this, and like that, and like this. These are the compression lines. Why? Because when you get to the middle, all of the middle is going to contribute to balance that stress. But now, because of the curvature of these lines, this one over here and this one over there, there is going to be a component of those two that is going to go in that direction. And those are going to be those tensile stresses. So if you have an element of rock here in the middle, you're going to have tensile stresses on the sides and compression in the other direction. So when you do this test, simply what you're going to have to do is to measure what is the maximum force as a function of time at which the rock breaks. You're going to see this looks something like this. That maximum force, we're going to call it PV, and the tensile strength that you get from this equation is going to be equal to the maximum force divided pi times L times R, where L is the length of the cylinder and R is the radius of the cylinder. And that's going to be the value of tensile strength. You need to be a little bit careful with these kind of tests. Ideally, you want the length to be equal or larger than the diameter. Otherwise, you may run into some imperfections. And you need to make sure that your load is well centered. So when you run the tests, make sure that the sides are parallel. So if I look now from the side, you want your lower plate to be parallel to this side, and you want your loading, I think here you have a loading screw. You want your loading screw also to be parallel to that face. This is okay. If you have something like this, that's not going to be okay, all right? Because that's going to give you some other value. It's not going to distribute the force as well. So, can you tell me more or less what is the typical, what do you think is the typical tensile strength of a rock? So I'm going to put an axis here. This is 0. This is TS, tensile strength. Let me tell you what is the tensile strength of stainless steel. It's about 40,000 psi. So that means that you can, if you had a bar with 1 inch square area, you can hang from that 37,000 pounds, okay? So 37,000 pounds, how much is that? That would be like 60, 70 tons, right? Let's say 70 tons. So 70 tons would be no, it would be like 30 tons. No, 37,000 pounds is going to be
2 metric tons.
No.
A little bit less than that.
It's going to be half of this. So it's going to be like 18 tons. 18 tons. Let's say one car is 1 ton, 1 metric ton. So you can hang 18 cars, okay, from a stainless steel rod without breaking. What do you think about a rock? If I gave you a rock with a 1 inch square diameter, what do you think is going to be the tensile strength of that? How many cars do you think you can hang from a rod of rock of 1 inch square? No? 0 cars? Any other number? Talking in terms of cars.
Considering just from last week's lab, they all collapsed at 3,000 pounds.
No, but you were doing unconfined compression strength, which is something. It is not the same. This is tensile strength. Okay, we're gonna get to unconfined compression strength later on. But in general, rocks cannot resist a lot. Okay, usually the tensile strength of rocks is gonna be more or less than 10 MPa, which is about 15 psi, 1500 psi, which would be more or less the weight of a small car, or the weight of a big Longhorn. So that's how much you can hang from a rock, and would be a very good rock. You're going to see later on that there are some other rocks that are much softer than that. All right, guys. So this is all you need for the lab on Tuesday. You're going to measure those values, and then we're going to discuss about that on Tuesday. All right. So have a good weekend. Do your homework, and let me know if you need any help. Prepare for the exam.